Yeah, many thanks, Tamar, thank you. And congratulations really to the Royal Society for really pioneering and for really fostering innovation and exciting new thinking in this area of One Health, planetary health, whatever you want to call it. And a lot of what I'm going to say is, as we've already heard, based on the work of the Commission. Quite a lot of developments since then, which we'll talk about perhaps a bit later on. People sometimes ask, well, what is this concept of planetary health? And the way we defined it, very simply, was the health of human civilization and the state of natural systems on which it depends. So it differs from this concept of global health, which doesn't really take into account the sustainability of the current improvements in human health. And we have seen very dramatic improvements in human health over recent decades, more than 20 years increase in life expectancy, for example, dramatic declines in infant and maternal mortality. But those improvements have come at a cost, and the cost is largely borne by the environment. And those changes, we believe, will have increasing implications for human health and could undermine the progress that we've seen in recent decades. So this slide is not intended to be read in detail, but it's to give you a kind of visual representation of what is now called the Anthropocene epoch. So the Anthropocene is an epoch in which one species, that's our species of course, is dominant. And the effects of the Anthropocene are pervasive, they're seen throughout the planet. Of course they will impact asymmetrically on human health and development, bearing down particularly on people who are vulnerable, who live at the edge of environmental adaptation to the environment. So on the left you see the socio-economic trends, which are summarized, for example, population growth, increases in GDP, consumption of fertilizer, energy use, which of course has been necessary to power this dramatic economic growth, water use, and so on. And on the right you see the Earth system trends. So that's the way in which the Earth systems are responding to these drivers on the left. And you can see that there are dramatic changes occurring in them. Climate is an obvious one, 1 degree warming since pre-industrial times, but many others as well. Acidification of the oceans, for example, as CO2 dissolves in the oceans, they become more acid. A dramatic increase in the loading of nitrogen and phosphorus, for example, in fresh and marine ecosystems, and dramatic changes in land use with that degradation of many ecosystems, deforestation, particularly in the tropics. So this is a famous slide which comes from a paper more recent. They published originally, I think it was in 2010 or so in Science, but they now updated their analysis of planetary boundaries. Johan Rockstrom and Will Steffen. I think, Kate, you're going to talk about this later on, how we can reconceptualize this a bit, but this is a very seminal illustration, and it shows you how humanity is essentially pushing up against and sometimes breaking out of these boundaries within which human society was able to flourish and develop over the 11,000 years or so of the Holocene epoch. So the Holocene epoch was that historical epoch when the climate was quite stable, and the Anthropocene epoch will be a very different experience. And you can see that some of these boundaries are already being breached. For example, nitrogen and phosphorus, I've already mentioned. Biodiversity decline, climate change, we're probably on the edge of reaching the boundary beyond which there will be very serious implications for humanity. And some we don't know what the boundaries are. Indeed, there may not be a single boundary. I mean, novel entities like chemicals, for example, there's unlikely to be a single boundary. There'll be all sorts of different boundaries. So this is just one example, one illustration of a potential future. It's taken from the IPCC, and this compares two very starkly different futures. One is the 2 degree warming, which is still too much, but at least would provide us a reasonable chance of adapting, human society of adapting. And the other is a future of unrestricted, unrestrained greenhouse gas emissions, which would take us towards 4 degree mean warming by the end of the century, completely unprecedented rate of warming. And that, of course, takes us very much into uncharted territory, and we're only just beginning to understand what the implications for humanity would be if we do go down that pathway. The Paris Agreement, of course, was a necessary first step. We've already heard the US intends to pull out of it. It's not quite clear what implications and whether, in fact, in the end, they will pull out. I presume they will, but I think the final day in which they can pull out is the day after Donald Trump's term of office finishes, so we'll see what happens. But what we do know is that global surface temperature rise is likely to exceed 1.5 degrees relative to 1850 for all of the credible scenarios. It's very unlikely we're going to stay below that. So this, as I say, will have pervasive impacts on human health. This slide is just one example of one of the most obvious, the kind of direct effects, if you like, and this is the exposure to unprecedented heat stress, thermal stress, late on in the century. It's taken from some unpublished work that we and others, particularly led by George Kjellstrom and Corinne Le Carré, have been doing. And the map just shows you where the orange and yellow and red, where populations will be experiencing unprecedented levels of heat stress towards the end of the century if we go down a scenario in which we don't really radically reduce greenhouse gas emissions. And that will have profound effects on human health and development. It will mean that many people won't be able to work out of doors for a high proportion of the day during the summer months, for example. That has massive implications for subsistence farmers throughout sub-Saharan Africa and South Asia, but also people who are working in cities. In cities, the effect is amplified further by the urban heat island effect, so cities are warmer than the rural areas that surround them, and there's a lot of variation within cities as to how big that urban heat island effect is. So we're still beginning to understand the implications of that for health, and I can come back to that in discussion if we have time. But it isn't just the direct effects of climate change, it's also the less direct effects through changes in ecosystems, through changes in crop yield. It's one slide that illustrates the likely changes in crop yield with 3-degree warming by the middle of the century or so. And the red areas show you where crop yields are likely to decrease, and the green where they may increase, at least temporarily. We don't know what will happen in the latter part of the century. It's possible, though, that even in temperate climates, crop yields may decrease. Depends on adaptation. But what you can see is that many low-income countries are likely to suffer from decreases in crop yield at a time when we need to increase crop production to deal with the demands of a growing world population and, of course, increasing demands for animal products. And we feed, of course, a lot of crops to animals. But it isn't just climate, it's also other environmental changes, and here's another example. This is some work by Sam Myers' group at Harvard, and what they've done is to model the effect of loss of pollinators on nutrition. At the top part of the slide shows you where there'll be adverse effects on non-communicable diseases, because these pollinators are required for fruit and vegetable consumption. Fruit and vegetable consumption is a very important protective factor against NCDs, and therefore if you cut people's vegetable and fruit consumption, which is suboptimal in many societies anyway, then you increase the risk. At the bottom, it shows you where malnutrition and communicable disease may increase, because in those countries many of those crops are important for vitamin A, for example, which is a very important nutrient. So if we put those together, if we lost all pollinators, which is unlikely, but it's a kind of dose-response relationship, then you might increase deaths by perhaps 1.4 million additional deaths per year. So we need to think about climate change and multiple pressures on the food system all occurring simultaneously. Another example, which I don't have time to go into detail, is the way in which carbon dioxide fertilization is affecting the nutrient quality of crops. So as we put more CO2 in the atmosphere, it's not just causing climate change, it's also affecting the way crops grow. So it does stimulate growth of some types of crops, but it also lowers the levels of micronutrients in zinc and iron, for example. But it's not just these pressures, it's also water stress. Water stress, of course, is affected by climate change, by precipitation changes, but it's also affected by aquifer depletion. And this slide shows you where there's water stress by country. You can see that the brown and the red is where there's high and extremely high water stress. So even if we didn't have climate change, we'd still be depleting these finite fossil freshwater reserves, which can't be replenished on human lifespan. So you can see, for example, the Arab world, its per capita availability of fresh water has declined by about 75%. over the last 50 years or so. So that will have big implications for crops, for industrial production, even for energy, because a lot of water is required for cooling and so on of energy facilities and hydropower. So, for example, for a country like India, India would be suffering multiple stresses at the same time: population growth, dietary change, which is occurring in India, groundwater depletion, decreased availability of glacier melt from the Himalayas, for example, changes maybe in monsoon intensity, and climate change. So these multiple pressures together are not fully understood. The impact's not fully understood. And indeed, we, under Alan Dangour's leadership and others, are beginning to look at the effects of these multiple environmental stresses on food, nutrition and health. This is just to remind us that we need to increase food production, which shows you the projected needs for increased food over time to cater for these growing population and growing demands. And you can see that we need to increase food production at a historically unprecedented rate at a time when we have these multiple downward pressures on the world food system, which will be particularly seriously experienced by those who are, of course, most vulnerable. But it isn't just land systems, it's also marine systems as well. You can see this slide taken from a paper in Nature in 2015 shows us how fisheries are declining in many parts of the world. You can see that there's now a definite decline in the total fish catch around the world. That's due to overfishing, much of it. 9% of the world's fisheries are fully or overfished. And in future, of course, climate change will add to that, because that's going to displace many fish species northwards, so to take it away from some of the poorer tropical and subtropical countries. We've already heard that aquaculture is very important, but of course a lot of aquaculture is not very sustainable either. You can see here the nutritional vulnerability to fishery decline. I don't know how clearly it's showing up, but this slide just tries to illustrate, particularly in terms of the orange areas and the yellow, where there's likely to be particular susceptibility to malnutrition as a result of fishery decline, because these communities are very dependent on fish for their protein consumption, for micronutrients, and obviously for their economic and livelihoods as well. So increased vulnerability across the tropics and subtropics to fishery decline. But there are also other changes occurring as well. One of them is the way in which salt water is intruding into the aquifers in many countries. This is coastal Bangladesh, work led by my colleague Pauline Shielbeek at the London School, colleagues at Imperial College as well. And they've shown how the increased salination of coastal water supplies is affecting blood pressure in pregnant and non-pregnant adults, and also causing an increased risk of adverse pregnancy outcomes. So devising strategies that will help these coastal populations adapt to more saline water, using rainwater harvesting. There are various other possibilities which could be used over time, but we need to develop those strategies now. And of course this has been thrown into sharp relief by the current tragedy, the Rohingyas migrating into these kind of areas and putting more stress on limited water supplies. Wildfires, as we've seen in the west coast of the States, becoming probably more frequent. And this is a study looking at the El Nino, so it's not human-induced climate change, it's the El Nino, but it's an interesting kind of case study, if you like. And what it shows is that there were massive fires in Sumatra and Kalimantan in 2015, coinciding with the El Nino then. And it's been estimated that the particulate emissions from these fires could have caused perhaps 100,000 additional deaths across these countries, particularly Indonesia, but also Malaysia and Singapore and others. And at one point, the daily emissions from Indonesia exceeded those of the whole US economy. So the burning of these forests, the burning of the peat, was actually emitting enormous amounts of greenhouse gases as well. So developing strategies to reduce this kind of burning and to contain it are going to be really important, because forest fires, wildfires are also an important driver of biodiversity loss. Does environmental change increase the risk of conflict? Well, some researchers have suggested that it does. And this is a meta-analysis by Solomon Siang and colleagues in Science a few years ago, where they showed, using studies since 1950, that there's a relationship between warmer temperatures or more extreme rainfall and the frequency of different types of violence, interpersonal violence, civil war incidents, and so on. This was a much discussed paper at the time. Some social scientists felt that they'd be too simplistic in their analyses, but I think actually the broad associations do hold up over time. And there's also added evidence in the form of a number of case studies. One of them is the Syrian conflict, where the risk of drought, which seems to have triggered the Syrian conflict, was more than doubled by climate change. And this slide just summarizes the timescale of events that led up to the Syrian tragedy. And you can see that there was an unprecedented drought starting in around 2000, something like that, but really coming into full force between 2005 and 2010. And that seemed to force people off the land into the cities, created political turmoil, and of course, as we know, an autocratic and repressive government reacted by clamping down, and the conflict then broke out in many parts of the country. So climate change may act as a kind of trigger. It's not necessarily a direct cause, but it may act as a trigger for conflict and other environmental changes as well. And as we've heard very eloquently from David earlier in his presentation, many of the drivers of the recently emerging infectious diseases in humans are from wildlife. So this is taken from the CBD report, the Conventional Biological Diversity report, and you can see that land use change, food industry changes, travel and commerce, war, climate and weather are all playing a role in the emergence of infectious diseases in humans from wildlife. And they are likely to get more intense and more important in years to come. So I've outlined some of the real challenges for humanity, but I want to, in the last part of my talk, just to discuss some potential solutions. Because clearly, we kind of sit back and wait for things to happen. We have to try to develop policies which will both safeguard human health, but also help to stabilise environmental degradation. And in the Commission report, we identified three types of challenges: what we call imagination challenges, knowledge challenges, and implementation challenges. So imagination was really, these are conceptual challenges. So for example, we tend to put the growth of GDP as the main metric by which we judge the success of society. If you listen to our own politicians, they really only talk about economic growth, not very much else. And yet economic growth is a very poor way of demonstrating human progress. And it can be inequitable, from the one point, but it can leave many basic needs unsatisfied. And I think we'll hear later on in the discussion probably some more critiques of that. So we need to reconceptualize metrics of human progress, which will more accurately measure not just the progress of humanity in terms of health, education, development, but also the sustainability of that progress. Secondly, knowledge challenges. And until very recently, there's been virtually no research in this area. It's really quite striking when you consider the billions and billions of dollars spent on biomedical research, and of course we're all in favour of that, we want to see that maintained. But the fact that very little money has been spent on this kind of research is really very striking. And I know we're going to hear later from the Wellcome Trust, who've really been leading the way in financing a growing body of research in this area. And then finally, implementation challenges. So in some cases, we do know what we've got to do. We know we've got to decarbonise the world economy, but we're not doing it quickly enough. And there are various reasons why that's so, including, of course, massive vested interests that are not prepared to give up their big investments in fossil fuels and obsolete technologies and so on. So let me just touch on one or two kind of key headlines of ways forward. Firstly, decarbonising the economy. Well, that will bring with it many, many benefits to human health. One of them is illustrated in this slide from the World Energy Outlook Special Report. And what the International Energy Agency showed was that with a relatively modest percentage increase in investment, we can move towards a clean air scenario with much greater generation of energy from renewable sources than today. And that could save over 3 million lives by 2040, whilst providing energy access for all, lower energy import bills, and leading to a peak in carbon dioxide by 2020, which is about what we need to be aiming for. We need to be peaking and then coming down very quickly. So in proportionate terms, that's a fairly small increase in investment. Remember, we've got to invest a lot anyway in infrastructure and energy, even without climate change. The second point is cities. Most of the world's population now lives in cities, so any solutions that we may have to focus, not to say we neglect rural populations, but they will have to be implemented in urban areas. And this slide just allows me to kind of illustrate, if you like, the tale of two cities. On the left there's Atlanta and Georgia, on the right is Barcelona. They both have similar populations of 5 million people. They have dramatically different urban areas, so about 10-fold difference in urban area of Atlanta compared with Barcelona. And they have dramatically different transport greenhouse gas emissions, because in Atlanta you have to use a private car often. And in Barcelona you can use public transport, walking and cycling. So dramatic per capita differences in transport carbon emissions. And I would say also big potential benefits for public health. So using public transport gets people walking. Active travel, walking and cycling, of course, reduces the risk of 7 conditions that are related to sedentary lifestyle. So about 3 million deaths a year around the world related to sedentary lifestyle. So it's really the only way we've got to get large numbers of people exercising is by giving them better opportunities in their daily living and transport. So we need to focus on cities, and we need to develop better policies around transport and infrastructure and so on. This just summarises some of the urbanisation trends in Africa. And it's in Africa where we really have the potential to redesign better cities from the outset. Because in Africa, many of the cities that will be in existence by the end of the century are currently being built, or will be built over the next few decades. And you can see some of the dramatic changes, both in terms of growth in existing cities like Dar es Salaam, Nairobi, Kinshasa, Luanda, and so on. But also, as I say, many of the small cities not on this map, now they're towns, are going to develop very dramatically. So if we can get it right in those cities and build more pleasant cities which are based on public infrastructure, more livable cities, then we can, at least in theory, safeguard the health of many hundreds of millions of people over time. We're also becoming increasingly aware that there are many benefits from exposure to green space. And this slide just summarises some of the mental health benefits from exposure to green space. The vertical line is zero effect, and you can see that exposure to green space, this is from a systematic review done some years ago, exposure to green space reduces displeasurable moods and increases pleasurable moods, according to a number of different studies. So it does seem that there is something about regular access to green space which does seem to improve people's mental state. And if we can design cities which provide access to green space, we can also protect biodiversity in cities. Green space can also help to store water, for example, but also maybe improve mental health as well. Sustainable transport I've already mentioned, but this slide really just summarises how some of the innovations in transport, sustainable transport, are really scaling up very rapidly. So there are things like public transport, car-free zones, bus rapid transit systems, car sharing, bike sharing, low emission zones and so on. You can see that they are scaling up mainly in high income cities, but increasingly hopefully in low to middle income cities. And there are some like Curitiba in Brazil, for example, which have been pioneers in scaling up access to public transport with undoubted health benefits. So there's a lot that cities could do for planetary health: clean low carbon energy, improved water sanitation, green spaces, and better public transport, active travel. But we're also becoming increasingly aware that forest conservation, for example, can reduce disease risk. We've heard something from David about some of the risks of exposure to infectious disease agents in forests, but there are also benefits for conserving forests. And this is a study from the Brazilian Amazon, which suggested reduced malaria transmission, reduced air pollution, and cleaner water, because intact forests can help to filter microbes out of water. So there's an increasing body of evidence that forest conservation can also benefit human health. Coastal conservation as well. Ecosystem strategies can increase disaster resilience. Just some examples here. Mangroves act as a way of buffering coastal communities against storms, and coral reefs protect fisheries. Addressing unsustainable food systems is going to be, we're going to discuss it I think later on today, but essentially nearly 30% of the world's total agricultural land is used to produce food that's never eaten, and the food system is a major contributor to greenhouse gas emissions, particularly of course our dependence on animal products. So we need to move towards increased intake of plant-based diets and reduction in dependence on animal products in high-income settings, not in all. The Sustainable Development Goals are dramatic potential for us to integrate human health and sustainability. There's this one SDG number 3, which is about health, but many of the others, of course, around energy, poverty, food, agriculture, cities, are all have the potential to greatly support and transform prospects for health. We need to try to look for technologies that provide disruptive change, and this shows you the Easter parade in Fifth Avenue, New York, 13 years apart. In 1900 there were no cars, it was all horses and carriages. By 1913 there were no horses and carriages or only cars. Now that may be a kind of disruptive change that we're now beginning to feel the adverse effects of, but it was a very, very rapid transition. Can we have another rapid transition over the next decade or two, which will take us into a more virtuous direction? As one vision from a designer here of new forms of transport, which will be much cleaner and also promote physical activity. So in closing, let me say that we are faced by very profound challenges, probably unprecedented challenges, that threaten to undermine and perhaps overturn the advances we've seen in human health and development. But I think there are a number of solutions that lie within reach, and we need to base these partly on the redefinition of prosperity, to focus on quality of life, but also to combine this with greater respect for the integrity of natural systems. Thank you very much indeed.